Hello geometry students, this is Mr. Fugay, and I'm going to talk to you in this video about an introduction to the triangle side angle relationship activity. So what am I talking about here? Well, I want you to think about this question. You see up here it says prediction. What do you think the relationship is between the location of the largest angle of a triangle with its largest side? Meaning, if you know where the largest angle of a triangle is, can you locate the largest side without knowing its measurements? And I want to reverse this. Does this relationship apply to the smallest angle and the smallest side? Or what if I knew one of the side lengths and it was the longest? Could I find the largest angle? Well, take a moment if you want and jot your ideas down here to the right of where it says prediction. Because what we're going to do in this activity is you are going to work through some examples to help you generate a rule for this. And we're going to do that by going to Desmos. So this link right here is going to bring up a triangle that I've already constructed for you. So let's hop over to Desmos, and here it is. Now you'll notice on the first task that it says for triangle 1 that we want C to be our largest angle. So I'm going to demo this one. You of course can do your own. I would actually recommend that you do your own on purpose so that maybe you can compare your answers with my answers. So here we go. So I need to make C a large angle. Now currently it already is, but let me show you here because you can take these vertices and move them around however you want, and it's going to tell you the measure of the angles, knowing that they add up to 180 by the way, as well as the sides. So let's make C kind of really, really big, like 139.7. All right, so let's do this. Let me go and see if I can do a split screen. There we go. All right, so let's go ahead and fill this in. So our largest angle is angle C. Now, what is our medium angle? Well, we have 17 and we have 22. It looks like for me, that is going to be angle B. And then lastly, my smallest angle in this case is angle A. Okay, I'm not concerned about the actual numbers. You don't have to fill those in. I just want to know the ranking of those angles. And now we're going to do that with the sides. So which segment here is our longest? It appears that the segment across the top here, segment AB, is my longest segment. Next is going to be, it looks like 6.8, and that is segment AC. And finally, my smallest is going to be segment CB at 5.5. Now, I want you to try this yourself and fill this in as well. And then if you have any notes or thoughts, maybe if you're starting to generate a reason or a relationship from this objective, start writing those ideas down. If not, move on to the second triangle. And in the second situation, I want you to make C the smallest angle. And so maneuver the triangle the way that you need to for that, and then go ahead and redo the rankings. And then we move to the idea of making segments long and making segments short and looking at how that affects the ranking of our angles, of what the largest, the medium, or the smallest angle is. The idea is that at the end of this, you will generate a rule or a procedure for someone to rank the angles from least to greatest given the 3 side lengths of a triangle. And also how to rank the sides from least to greatest when given the 3 angles of a triangle. Once you're able to figure that out, then you're going to turn to page 2 and 3 of this and be able to put it into action. So best of luck to you. Let me know if you have any questions as you're working through this activity, and have a great rest of your day.